Hey everyone, and welcome to This Explainer. Today we're diving into something that is incredibly close to my heart. Honestly, it's a topic that has the power to completely revolutionize how we teach fundamental math. We're going to be looking at a program called Matemáticas en Movimiento, or Math in Motion. And this is really all about taking the fascinating, cutting-edge science of neuroeducation and applying it to something that has troubled kids for generations, learning multiplication.
Okay, let's be real for a second. Do you remember the stress and anxiety of mechanically memorizing your multiplication tables? Because I know I certainly do. For so many of us, it's this deeply relatable shared childhood trauma, right? Filled with sweaty palms, ticking clocks, and just the intense, crushing pressure of rote memorization. It was always this stressful hurdle you just had to jump over, rather than, an actual joy to experience.
All right, let's jump straight into Section 1. El problema de method traditional, or the problem with the traditional method, who exactly gets left behind?
So for decades, it's like we've treated developing minds as simple recording devices, rather than the complex dynamic networks they actually are. The traditional methods we all grew up with rely heavily on sheer repetition, mechanical memorization, and this absolute obsession with speed. Plus, the practice is completely decontextualized. It's all about how fast you can shout out a number, without building any actual conceptual understanding of what that number means or how you even got there. It's a super rigid and honestly punishing system for a developing brain.
So who ends up paying the price for this outdated setup? Well, it actively alienates students who already suffer from mathematical anxiety. It totally sidelines kids who thrive as visual or kinesthetic learners. And furthermore, it completely abandons the students who simply need to comprehend the why before they can confidently automate the what. By demanding raw speed over logical sense, we're essentially locking them out of the subject entirely.
Moving on to Section 2, La Solución Neuroeducativa and how the brain actually learns.
Now, here is the really exciting part, because we're stepping into a much brighter, science-backed reality. What exactly is neuroeducation? Basically, it's a powerful framework proving that the human brain absolutely does not learn best through dry, endless repetition. Instead, it actually thrives on understanding patterns, connecting genuine emotion to the learning process, and actively using multiple sensory channels. The science is totally clear on this. The brain requires an emotional connection and active, multisensory participation to truly retain knowledge and build deep neural pathways.
So we're literally looking at a clash of two totally different paradigms here. On one hand, you have the punishing, mechanical focus of the past. Speed, blind repetition, called mechanics. But on the other hand, you have the engaging, modern demands of neuroeducation, which is all about comprehension, emotional resonance, and rich multisensory input. It's basically the difference between forcing a square peg into a round hole and actually nurturing a child's natural, built-in curiosity to learn.
Which brings us to Section 3, Matemáticas en Movimiento, bridging understanding and memory.
Enter Matemáticas en Movimiento. This is the ultimate neurodidactic system designed specifically to cure those exact pain points we just talked about. And listen, it isn't just about finding some sneaky new trick to force memorization. Not at all. It's this beautifully structured system that seamlessly weaves together comprehension, memory, actual play, physical movement, and striking visual representation. It uses strategic practice to make sure the learning actually sticks, making the whole experience super dynamic and, dare I say it, genuinely fun for the student.
Let's break down how this actually works in Section 4, Dos Metodologías Clave, the dual engine of learning.
To pull off this incredible balance of deep understanding and rapid retention, the system is powered by two really innovative methodologies that work together. On one side, we have Jumping Jack, which is all about building that deep logical comprehension, discovering patterns, and encouraging flexible thinking. It totally reduces the cognitive load. Then, on the flip side, we have Color Mix. This methodology uses visual memory and brilliant chromatic associations to achieve rapid, automated retrieval. So one builds the solid foundation, while the other builds the necessary speed.
But how do we put this into practice? Let's look at Section 5, La Secuencia de Aprendizaje, the path to automation.
Now, you can't just throw these methodologies at a student randomly and hope for the best, right? Merging them requires a very specific journey, universally known as the CRA sequence. First up is Concreto. The student starts by physically touching and manipulating real concrete objects. Then they graduate to Representativo, where they begin to visualize and draw out these concepts. And finally, they move to Abstracto, engaging in pure mental math with numbers and symbols. It's brilliant because it perfectly honors the brain's natural developmental stages.
And let me tell you, when a student actually follows this specific, structured journey, the results are simply incredible. As they actively comprehend the core concepts, discover the mathematical relations, rely on visual supports, and practice dynamically, they finally reach that ultimate goal of automation. Integrating understanding with memory in this exact intentional order leads to immensely higher retention, way better transfer of skills, and true mathematical fluency.
Let's talk about where this really matters in Section 6, Beneficios y Aplicación Práctica, real-world impact in the classroom.
This is where the magic truly happens. This method is an absolute game changer for our most vulnerable learners. We're talking about students with strong visual or kinesthetic needs, those crippled by math anxiety, kids with ADHD, students on the autism spectrum, and basically anyone who chronically struggles with traditional rote learning. For these kids, we see a massive reduction in frustration and a huge, life-changing boost in their personal confidence.
And what makes it even better is how completely adaptable the entire system is. You can seamlessly roll this out in regular everyday classrooms, specialized workshops, targeted psychopedagogical support sessions, extracurricular academies, or specialized learning centers. Because it uses engaging games and group dynamics, it easily fits right in wherever students happen to need it the most.
We do have to keep the big picture in mind, though. The ultimate goal here isn't just getting a kid to spit out fast answers to pass some standardized test. No, the real goal is to develop lifelong strategic thinking, personal autonomy, internal security, and a genuinely positive relationship with mathematics. Because at the end of the day, our brains learn best when things actually make sense to us.
Hacemos de las matemáticas un juego de niños. We make math child's play. I want to highlight this quote because it really serves as the emotional heartbeat of this entire neuroeducational shift. Mathematics is no longer a punishing chore or a source of tears at the kitchen table. When it's taught correctly, using these principles, it literally becomes as natural, intuitive, and engaging as play.
So, as we wrap up this explainer, I want to leave you with a final provocative question to reflect on. How will you change your teaching approach today to build mathematical confidence rather than anxiety? Whether you're an educator, a parent, or just a lifelong learner, the science is beautifully clear. It's time we ditch the rote memorization for good and start putting math in motion. Thanks so much for joining me today, and I hope you leave feeling just as inspired as I do.